So here's the one slide. There's two things you need to know about slant asymptotes. How do you know when you have one? And then once you've identified that we've got a slant asymptote, second one then is, how do I know where it's located? Okay, when and where are the two questions we're going to answer. So question number one, how do you know when? It's when the numerator is top heavy. Okay, when we're still looking just like horizontal, we have not had this case yet, but whenever the degree of the numerator is exactly one more than the degree of the denominator, okay, whenever it's top heavy by one, that's how you know you've got a slant asymptote. So if you had a cubic function on top and a quadratic on bottom, you've got a slant asymptote. If you had a quadratic on top and a linear function on the bottom, you've got a slant asymptote. Okay? Which means you don't have a horizontal asymptote. You have a slant asymptote instead. Yeah?
What if it's like a 4 and a 2? It's more
There's still an asymptote, but we're not going to worry. We're not going to get to that point. If you noticed on one of the sheets last week, they talked about oblique asymptotes. That's why we're going to deal with slant asymptotes. You could have a like parabolic asymptote. That's what would happen in that scenario. We're not going to get to that point. We're not going to worry about that. Okay? But it is a thing. So in this scenario, like I said, that's how you know when you have one. Okay? Top heavy by one. Then the next question is, how do I actually find the slant asymptote? Where is it located? And quite simply, in order to find the equation, you're going to do long division. Okay? You're going to actually do numerator divided by denominator and see what you get. The answer that you get, ignoring the remainder, will be the equation of your slant asymptote. Okay? You're going to do long division, ignore the remainder, and that'll give you the equation of your slant asymptote. And that'll be, I told you, the quiz, the assessment, whatever you want to call it, coming up on Thursday. Like I said, it's only 4 questions. Some of them will have slant asymptotes, some of them won't. That's what we're going to kind of do in the next couple of days is, here's some problems, you identify when this happens. Okay? All right, so there's the when and the how. How do you find it? Now, let's actually get into some examples. Let's work our way through it. Let's actually deal with the slant asymptotes. So if you notice, first of all, if we're identifying, notice I put down SA rather than HA now, okay, because we do have a slant asymptote, not a horizontal one. How do we identify it? Notice I've got an x squared and then an x, okay? So so the degree of the top is one more than the degree of the bottom. So that means you have a slant asymptote. What we need to do is actually find that equation. Where is it located? So we're going to actually do long division with the 1 minus x squared divided by x, okay? As you do that, I'm going to go to the next page just so there's more room. When you do the long division, the 1 minus x squared, again, make sure the highest degree is first. So I'm going to actually go negative x squared first. We'll put in a plus 0x, and then we've got a plus 1, rather than doing 1 minus x squared. You want to start with the highest degree. And then we're dividing by x. The good news is, even though we're doing long division, whenever you're doing the slant asymptote, it's going to be a pretty quick long division. It's not going to be very long. This one in particular, x times what gives me negative x squared? Well, we end up with a negative x. You multiply, I get negative x squared. You subtract or add the opposite, which means those cancel out. And now here's why I said it's not going to take very long. You bring the 0x down, I could bring the 1 down as well. Well, in this case, x times what gives you 0x? Well, technically it's plus 0, okay? Which I don't really need, and now we're getting into the remainder. And remember, I told you before, you're ignoring the remainder on this. You don't care about the remainder. So what this tells me, this is the equation of my slant asymptote. Okay? So if I go back, y equals negative x is the equation of our slant asymptote in this case. Okay? If you want to put the plus 0, we're actually in y equals mx plus b form, so it's fairly easy to graph. So if we add that to our graph then, we know at the origin, I have a point there, and then a slope of negative 1. Okay, just add some extra points to it. And there's your slant asymptote right there. Okay, y equals negative x. So we'll see how that affects the graph when we get into it a little bit more. But instead of having a horizontal one, we've actually got a slanted asymptote in this case. The good news is, basically the rest of this is the same as what you were working on last week. Okay, so if we start taking a look at holes in the graph, vertical asymptotes, all that kind of stuff, again, I would suggest you factor so you can see what you're looking at, and then go from there. So 1 minus x squared technically is a difference of squares. It's just written backwards. So I can factor this as 1 plus x and 1 minus x. And now that it's in factored form, now I can start answering some more questions. Do I have a hole in the graph? Is there a hole on this one? What do we think? Yes, no, maybe? Why not, Jack? You're right, by the way. Yeah, there's no factors that are canceling, right? That's what you're looking for. That's what George told us before. If there's factors that cancel, then that means that you've got a hole in the graph. In this case, there isn't any. So, none. No hole. Okay? Vertical asymptote at x equals what? X equals 0. Because, in this case, that's where the denominator would equal 0. And we can't have that, so that's where a vertical asymptote is located. So in that case, let's put that in. There's our vertical asymptote. And now we can find the intercepts, and if we have any cross points, we'll take a look at that as well. X-intercept, remember we said it's when y equals 0, it's wherever the numerator would equal 0. Which in this case, because it's in factored form, it's pretty straightforward. You're still just doing zero product property. So we've got when x equals negative 1. Oops, I forgot. And then you've got another x-intercept at x equals positive 1. Okay, so we've got two x-intercepts. One of them is right here. The other one is right here. Okay, which helps us with our graph here in just a second. Y-intercept is when x equals 0, but remember we said x can't equal 0, okay? Because there's a vertical asymptote there. So x is not allowed to equal 0, which means there is no y-intercept. And finally, you can't quite see it because it's hiding behind this, but we do have to check to see if there's a cross point, to see if the graph will cross our slant asymptote. Which means we do the exact same thing Miley said before. We said, take the equation, set it equal to the horizontal asymptote. This time we're going to take the equation and set it equal to the slant asymptote. Okay? So if we take a look, I'm going to do that on the next page as well. If I take 1 minus x squared over x, the actual equation we're working with, and I set it equal to our slant asymptote, negative x, which I'm going to write as negative x over 1. That way we have a proportion, and it's easy to just cross multiply them. Again, if I get an answer, okay, if I get an actual like x equals something, then I know that's the point where it would cross the slant asymptote. If I don't, then I don't have one. Okay? So if we take a look, when I multiply diagonally here, I get a negative x squared equal to 1 minus x squared. And now if you go through and you start solving for x, if you notice we start adding the x squareds, those will actually cancel each other out. You get 0 equals 1, which means you do not have a cross point on this one. Okay? This does not work out, but you still find it the same way. You set it equal to the slant asymptote instead of a number in this case. So, cross point, once again, we have none. Okay? There aren't any. So what does this graph actually look like then if we know that it doesn't cross any of these asymptotes? I at least have, here's what I want you how I want you to relate it to what we were doing. remember that the vertical asymptotes always cut the graph into parts. And then we're looking at, so to the left in this case of x equals 0, I'm looking at is the graph above or below. Normally, above or below the horizontal asymptote. In this case, above or below the slant asymptote. So since I've got this x-intercept, I know it's going to be in this area right here, which means I can go through and kind of sketch a graph. It's basically going to follow the asymptotes. There's graph number 1 right there. It's just kind of bounded by the asymptotes. It's just following that path. Then if I go to the other side, again, it's either above or below the slant asymptote. Because I've got an x-intercept, that tells me it's above. Same thing. It's just going to kind of follow the asymptotes. And there's what your graph will kind of look like. I didn't have to, in this case, I didn't have to do any extra test points or anything because of the fact that I already had some points that helped me out. We will have to do some test points, though, normally, just to see where the graph is. Let me stop for just a second. Any questions about slant asymptotes on this one, or anything not quite sure about where it came from? Because this is, like I said, other than the slant asymptote, everything else is pretty much the same idea. All right, let's do another one. Let's take a look. A little bit more practice here. I think somebody asked last week too, by the way, on your quiz coming up on Thursday, it will have all this stuff listed. You're not going to have to remember like what to find. It'll all be there for you. You just have to make sure you know how to do all of that kind of stuff. All right, so notice again, I do have a slant asymptote because I've got a cubic function on top, quadratic on the bottom, therefore top heavy by 1, okay? So in order to find the slant asymptote, the equation, I know it's going to be y equals something, I need to actually do the long division. Take x cubed and divide it by 2x squared minus 8. So, I'm not even going to go very far with it because, again, this is going to go pretty quick. Okay, it's not going to be a very long division problem here. So 2x squared times what gives me x cubed? Well, in this case, it's going to end up being 1/2 x. Half of 2 gives you 1. X squared times x gives you the x cubed. If you multiply this through, we would end up with x cubed. We would end up with minus 4x. And if you now start working your way through, in this case, we're back again to the whole like 0x squared, which means it's no longer a factor anymore. Now the rest of this is going to be a remainder, which I don't really care about the remainder. All I care about is the actual factor, the answer. So right here, 1/2 x, there's your equation of the slant asymptote in this case. Okay. So y equals 1/2 x. There's the equation of our slant asymptote. We can add that to the graph. Again, it's already in y equals mx plus b form. So plot your y-intercept, the origin, positive plus 0 if you will, and then use your slope to find the rest of the line. Up 1 over 2, up 1 over 2, both directions. And there's your slant asymptote for this one. All right, then we go back to the rest of it. Okay, once again, let's go through and factor so we can take a look at vertical asymptotes, holes in the graph, all that kind of stuff. If we do that, we've got x cubed on top. We can take a 2 out of the denominator. We can factor that out, which leaves us with x squared minus 4, which is a difference of squares, so we can factor that a little further. And now we can evaluate what we have, what we're working with. Do we have a hole in the graph on this one? What do we think? Any factors that cancel? What do you think? Nope, I see what I was going to say. I see some heads. Nope, in this case, there's nothing to cancel. Therefore, once again, there is no hole in the graph. Okay? Don't have to worry about it. Where do I have vertical asymptotes? In this case, I have 2 of them. Well, since nothing cancels, then we're still looking at the denominator and saying, all right, what values of x can I not have? Because that's where the vertical asymptotes are located. At x equals -2 and at x equals +2. So let's add that to the graph. X-intercept in this case. And this one's going to actually, again, it's when the numerator equals 0. Well, x cubed equals 0. That means the x-intercept is the origin at x equals 0. We have a point on the graph right there. What does that also tell me, by the way? That means I've got a cross point on this one because I've got an x-intercept that is on the slant asymptote. Which, if I'm taking a look, I don't even necessarily need to go through and find the cross point then, because I already know it's there. Okay, we happen to just find it just now. So we do have a cross point at the origin, which also means if the origin is an x-intercept, it's also the y-intercept, okay, because it crosses at the x and the y. So you actually found 3 things in one on that, with that being the point that we were finding. Now, unfortunately, that doesn't give us a lot in terms of the sketch of the graph. So here's where we got to go back to some of the test points. You have 3 different areas here. To the left of x equals -2, we have to figure out, is the graph above or below the slant asymptote? In the middle, we know it's going to cross, so we still got to figure out what it's going to look like in the middle. And then on the right-hand side, anything greater than 2, same thing, above or below the slant asymptote. So let's start over here to the left. I'm going to pick -4. If we take, part of the reason I'm picking -4, by the way, is I know this point is on the slant asymptote. I know it's at -2. So I'm going to check to see if the answer I get is above or below -2. That's why I picked that value. Okay? So if I plug -2 in, we get, or excuse me, -4 in. I'm going to pick -4 and see if it's above or below. What do we get? -64 on top. 32, 24 on the bottom, which is, in this case, if you take -64 and divide it by 24, it is less than -2. It's, or bigger than -2, however you want to say it. Which means we're going to be below the slant asymptote. So this first graph will be kind of somewhere sandwiched in here. Just like when you had horizontal, you're just figuring out, pick a value of x. Am I above or below the slant asymptote? Now, in the middle, 1 point doesn't tell me a whole lot. So in this case, what you should do is we should pick some other points to kind of see what's going on. So let's say that I pick -1, and we plug it in. And by the way, you can pick as many points as you need to. If you're not quite sure what a graph is looking like, you can go through and make an XY chart real quickly. Pick a value of x, plug it in, and see what the corresponding y value is. Pick a different value of x, plug it in, see what you get, okay? And so on and so forth. So if I pick -1 and I plug it in, what do I end up with? What do we get? +1/6. Yeah, I think +1/6 if I did the math in my head right. So we're, at least I know I'm above the x-axis. Okay? Doesn't help me a lot, but it gives me at least an idea. Let's say I pick +1 and I plug it in. Turns out you get a -1/6 as an answer then. So I'm a little bit below the x-axis. Again, that may not be enough. That may not help you enough. So you may want to pick -1.5 and plug it in. And you can use your calculator. You can get the values just to see what's going on. Ultimately, what's going to happen on this part of the graph, it looks something like this. It's kind of like that negative cubic function. It's kind of like an S-shaped curve. And then, last thing we still have to check on the last part, above or below the slant asymptote. So same thing I did over on the left, I'm going to do the same thing on the right. I'm going to pick positive 4, plug it in, and see if the answer is above or below. Okay? So if we plug 4 in, I believe you get the exact same numbers except for positive now instead of negative. I think we get right around something like right around 2.5, somewhere in that vicinity. Therefore, that means we're above, so the other graph will be somewhere in this vicinity. Something like that, again, sandwiched in between those asymptotes. This is about as complicated as it gets. Where we've got 2 vertical asymptotes, we've got a cross point with a slant asymptote. This is about as difficult as it will end up. Okay? The only extra thing that we really could have added was the fact that maybe it would have had a hole in the graph and define that, but this pretty much has everything else that could happen. Any questions before we go on? I got one more for you that I want you to take a look at just to kind of finalize this. All right, let's go to the last one then. Last one. Let's put it all together. Matter of fact, I'm going to give you a couple of minutes. You've seen a couple of problems now. Let's see if you can find the slant asymptote, the holes, vertical. I'll give you an opportunity to kind of put this together on your own here before I give you the assignment. Okay, so give it a shot. See what you come up with. Find all the important features and sketch a graph. If you get stuck on anything, let me know. I'll help you get past it as well. All right, let's bring you back together, see what you came up with, kind of check your work, see how you're doing on this. Again, we have a slant asymptote. Degree of the numerator is one higher than the degree of the denominator. So I need to find the equation, okay? Y equals something, okay? It's going to be linear. It's going to be, again, a line. So if we do the long division, we've got x squared plus x minus 2 being divided by, was it minus 3 or plus 3? Minus 3. X minus 3. So now if we actually do the long division until we get to the remainder portion, x goes into x squared, we multiply by x. Distribute, I get x squared minus 3x. And we subtract, or again, add the opposite. The x squareds cancel. Put those together, I get 4x, bring down the minus 2. Now in this case, this is the first example where we've had to keep going because x does still go into 4x. It is still a factor of that. So we're not quite done yet. I need to multiply by 4. So positive 4. Distribute, I get 4x minus 12. Again, either subtract or add the opposite. And we end up with, in this case, you end up with a remainder of 10, which we don't really care about. All we care about is the x plus 4. And therefore, that's where I've got a slant asymptote. The equation is y equals x plus 4. So now, we need to graph that. We need to graph that line. Y-intercept of 4 and a slope of positive 1. Okay? Therefore, up 1 over 1. So there's where the slant asymptote occurs. Now if we take a look again, let's once again factor and start to take a look whether we've got any factors that cancel. If we factor the numerator, we get x plus 2 and x minus 1. Any holes on this graph? No. Again, because there's no factors that cancel. If there was, we would have to find it. But in this case, there are no holes on the graph, so none on that case. Vertical asymptote where? X equals 3, because that's where the denominator would equal 0. So at x equals 3, we have a vertical asymptote. So right there. And now we find the rest of these. X-intercepts, wherever the numerator is equal to 0, which means we've got one x-intercept at negative 2, and we've got another x-intercept at positive 1. Right, so there are 2 of them. There's those 2 points. Y-intercept is when x equals 0. So if we plug 0 in for x and see what we get, doesn't matter whether it's the original or the factored, you should get the same answer regardless. Original is a little bit easier. You get negative 2 on top, negative 3 on bottom. So therefore 2/3 is your y-intercept. So right around here someplace, we've got a y-intercept now. And the only thing left to do is to see if we have a cross point. Does the graph cross the slant asymptote? So as always, we've got to take the equation and we've got to set it equal to the slant asymptote and see what we get. So if we do that, we've got x squared plus x minus 2 over x minus 3. And we're going to set it equal to x plus 4. Again, I'm going to put it over 1 just so it's a proportion and it's a little bit easier to work with. If we cross multiply, we've got this quadratic times 1, so we just end up with x squared plus x minus 2. When we do the other diagonal, you've got 2 binomials, you've got to FOIL it all out. Okay? X plus 4 times x minus 3. If we FOIL that out, we get x squared plus x minus 12. And now we start moving things around to see, do I actually get an answer for x, or again, does everything go away? Well, if you subtract x squared, regardless of which direction, those go away. If you start moving x's around and subtract that, those actually cancel out, and you're left with negative 2 equal to negative 12, which means you don't have any cross points. Okay? There is no value of x that would equal x plus 4, that would be on that slant asymptote. So cross point, once again, we can add down here, there isn't any. So, as we take a look, again, we're trying to figure out the graph. Here's kind of how we finally can put this together. The vertical asymptote, again, splits the graph into two parts, to the left and to the right. These 3 points tell me that the graph to the left is down here. So again, it's going to kind of follow the asymptotes, but also go through those 3 points. So it'll look something like that. It's got to go through the 3 points that we found, but at the same time not cross either of the asymptotes. And then the last part, we got to go to the right of the vertical and see, are we way up here in this kind of the small portion up at the top, or is it the bigger portion down below? So if we pick, let's see, that one's at 3, let's pick 4 and see what happens. If I plug 4 into the equation, again, either form, doesn't matter, what do we get? 18? Is that right? If you plug in 4, you get 18. That tells me we're way up here, which means the other part of the graph must be kind of sandwiched in there. There's the rest of it right there. Okay. Yeah.
On the test, are we gonna have graphs to write on?
Yeah, there'll be graphs. Yep. You'll have graph to put something on. You'll have all this stuff listed. It'll basically be just like this. It'll be, here's a problem, find all the stuff and graph it. Okay? Anybody have any questions? Otherwise, I've got a worksheet for you. Today I did not put the answer key with it because the answer key is like another couple of extra sheets. It's not just one extra sheet, but it is up here. So if you want to come up and take a picture with your iPad or with your phone, you're still welcome to the answer key. I just didn't want to have all the paper that had to go with it. Okay? So you're welcome to come up and take a picture. I will get you the assignment, and we'll go from there.